Good morning, students. Welcome back. So, today we'll be dealing with problem number 2 on thin cylinders. So, let me start with the problem. A cylindrical pressure vessel of 1 meter inner diameter and 1.5 meter long is subjected to an internal pressure P. Thickness of the cylinder is 15 mm. Taking allowable stress for cylinder material as 90 MPa, determine the magnitude of maximum internal pressure P that the pressure can withstand. Change in dimensions. Take Young's modulus as 200 GPa and Poisson's ratio as 0.3. Right? So now let me start with the solution part. Now there is one important thing which I need to note here in this problem. He has given something called as allowable stress for cylindrical material is 90 MPa. Right? So here we always need to remember that the maximum pressure is always found on the basis of circumferential stress. Right? He has asked me to calculate the pressure, maximum pressure that the body or cylinder can withstand. So always keep in mind this maximum internal pressure is always depending upon the circumferential stress induced. Right? It is always depending upon the circumferential stress induced. Right? So what I want to tell here is indirectly he has given us in the problem that circumferential stress is 90 MPa. Right? So let me put it in the form of words so that you can remember it, and whenever you are going through the notes it comes to your mind. The magnitude of the magnitude of maximum pressure, the magnitude of maximum pressure is found is found based on circumferential stress, based on circumferential stress. Okay, so therefore sigma c is equal to 90 newton per mm square. Right? So he has given to us that the allowable stress for the cylinder material is 90 MPa, and always keep in mind whenever you are designing a cylinder, the maximum stress which is induced in that is always the circumferential stress. Right? So in this case I'll take the allowable stress itself as the circumferential stress. So this is the key point here, sigma allowable. Okay, it should be always equal to circumferential stress because this is the maximum stress induced in the thin cylinder. Fine. So and if this is known, sigma c value is directly known here. So we know that sigma c is equal to PD divided by 2t. In some textbooks you will find it as PD divided by 2t. Both are same. In some textbooks you'll find it as small d, in some textbooks you'll find it as capital D, depends upon your convenience. Right? So if I just proceed further and rearrange things, I am in requirement of P. I'm in requirement of P also. I'll keep P on one side. So it is sigma C into 2T divided by D. This is the formula. So therefore P is equal to, what is the value of, therefore P is equal to, value of sigma C is 90 Newton per mm square. MPa he has given to us as MPa. So MPa is equal to Newton per mm square. So I have already shown you how in the previous videos. So I need not repeat this. I request you people to go back to module number 1 so that you can understand the unit conversions thoroughly. Right? So 90 Newton per mm square is the value of sigma c into 2 into thickness. So thickness he has given to me in the problem as 15 mm divided by diameter. So diameter is 1 meter. So 1 meter is 1000 mm, so you write it as 1000 mm. So therefore the value of P is coming out to be, so it is 15 into 2 into 90 divided by 1000. So it is 2.7 Newton per mm square. 2.7 Newton per mm square. Because it is pressure, the unit will be Newton per mm square. So this is the maximum internal pressure that the cylinder can withstand. Right? So I'll take this as 1. Now I'll go to the second bit. So what is second bit? He has asked us to calculate the change in dimensions. So whenever he asks us to calculate the change in dimensions, we should know epsilon L and epsilon C. So epsilon C is given by sigma C divided by E minus sigma L divided by ME. Sigma L divided by ME. So therefore epsilon C is equal to, so what is the value of sigma C given to me in the problem? So the value of sigma C given to me in the problem is 90 Newton per mm square. So let me put all those values. Sigma C is 90. Value of Young's modulus is 200 GPa, so it is 2 into 10 raised to 5 minus sigma L. Now here there is a key point, so I'll just write it later. This E is 2 into 10 raised to 5. Now here on this side I will be making some important calculations. So these are important. Now we know that sigma L is equal to PD divided by 4T. Right? So what I can write, sigma L is equal to PD divided by 2T into 2. I can split this 4 into 2 into 2. So what is this PD divided by 2T? PD divided by 2T, this particular thing. What is this? So PD divided by 2T is nothing but, therefore sigma L is equal to sigma C divided by, right? So therefore sigma L is equal to 45 Newton per mm square. 45 Newton per mm square, because sigma C is given to me as 90. So when it is sigma C divided by 2, so sigma L will be 45 Newton per mm square. Right? So value of sigma L here I should put it as 45, and 1 by m is nothing but the Poisson's ratio. What is the Poisson's ratio given to me in the problem? So if you just check out, it is gamma is equal to mu is equal to 0.3. It is also 1 by m. All are same, right? So 1 by m is 0.3. So now therefore epsilon C, if you just calculate, so let me check out, it is 90 minus 45 into 0.3, T minus 45 into 0.3, and that is divided by 2 into 10 raised to 5 divided by 2 into 10 raised to 5. So it is 3.825 into 10 raised to minus 4. 3.825 into 10 raised to minus 4. So it is 3.825 into 10 raised to minus 4. It does not have any unit because it is strain. So after calculating epsilon C, that is circumferential strain, I'll calculate change in diameter. So change in diameter, it is delta D is given by epsilon C into D. Okay, this we have seen in the previous problem as well. So therefore delta D is equal to, epsilon C value is 3.825 into 10 raised to minus 4 into diameter. What is the value of diameter? Diameter given to me in the problem is 1 meter, that is 1000 mm. So therefore delta D will be equal to, so let me check out, this is already there here, 3 point into 1000, so it is 0.3825, 0.3825 mm. So that is the change in diameter. So next, longitudinal strain. We know that longitudinal strain is given by sigma L by E minus sigma C by me. So it is once again the generalized Hooke's law. So therefore epsilon L is, value of sigma L is 45 divided by 2 into 10 raised to 5 minus 90 divided by 2 into 10 raised to 5. 1 by m value is 0.3 given to me in the problem. So therefore epsilon L is given by, so it is 45 minus 90 into 0.3, 90 into 0.3 divided by 2 into 10 raised to 5. So I'm getting the value as 9 into 10 raised to minus 5. 9 into 10 raised to minus 5. So that is the value of longitudinal strain. So change in length, so that is delta L will be epsilon L into L. So therefore delta L is equal to, epsilon L is 9 into 10 raised to minus 5, and a length of the cylinder given to me in the problem is 1.5 meters long, which is 1500 mm. So therefore delta L is equal to, so let me calculate, answer into 1500, so it is 0.135, value is coming out to be 0.135. So 0.135 mm, right? Next, at last, I need to calculate volumetric strain. So volumetric strain is given by the sum of longitudinal strain into 2 times circumferential strain, right? So if I just go ahead and place the values, longitudinal strain is 9 into 10 raised to minus 5 plus 2 into value of epsilon c is 3.825 into 10 raised to minus 4, 10 raised to minus 4. So therefore epsilon volumetric, so let me calculate, 9 into 10 raised to minus 5, 9 into 10 raised to minus 5 plus 2 into 3.825 into 10 raised to minus 4. So it is 8.55 into 10 raised to minus 4. 8.55 into 10 raised to minus 4. It does not have any unit. But epsilon volumetric is given by change in volume to original volume. So what it implies, I am in need of change in volume. So that is given by epsilon volumetric into volume. So therefore change in volume is equal to 8.55 into 10 raised to minus 4. So which is the value of epsilon volumetric into volume of cylinder is pi by 4 d square L. Value of d is 1 meter. So d square L is 1500. So therefore change in volume is given by into shift pi into 1000 square into 1500 divided by 4. So change in volume is 1.007 into 10 raised to 6. 1.007 into 10 raised to 6 mm cube. Mm cube. Right? So that's it. That is what is asked to us in the problem. So let us meet in next session. Till then, Take care. Bye bye.